Hi, my name is Susana Lokollo from Pharmacy A. Now we're gonna talk about chemical equilibrium. What is chemical equilibrium? Chemical equilibrium refers to the state of a system in which the concentration of the reactant and the concentration of their products do not change with time, and the system does not display any further change in properties. Table of content that we're gonna talk about chemical equilibrium is types of chemical equilibrium and factors affecting chemical equilibrium, example of chemical equilibrium, and the last one is importance about chemical equilibrium. The first topics that we're gonna talk is types of chemical equilibrium. There are two types of chemical equilibrium. The first one is homogeneous equilibrium, and the second one is heterogeneous equilibrium. Now we're going to talk about homogeneous chemical equilibrium. In this type, the reactants and the products of chemical equilibrium are all in the same phase. And homogeneous equilibrium can be further divided into two types. The first one is reaction in which the number of molecules of the product is equal to the number of molecules of the reactants. And the second one is reaction in which the number of molecules of the product is not equal to the total number of reactant molecules. And the second type is heterogeneous chemical equilibrium. In this type, the reactants and the products of chemical equilibrium are present in different phases. The second topic that we're going to talk is factors of chemical equilibrium. There are four points. The first one is concentration changes. The second one is pressure changes. Then temperature changes, and the last one is addition of a catalyst. The first factor is concentration changes. The concentration of the reactants or products added is relieved by the reaction which consume the substance which is added. The concentration of reactants or products removed is relieved by the reaction which is in the direction that replenishes the substance which is removed. And when the concentration of the reactant or product is changed, there is a change in the composition of the mixture in chemical equilibrium. The second factor is pressure changes. In pressure changes, the volume change, which cause a change in pressure. Since the total number of gaseous reactants and product is now different, a change in pressure can impact the gaseous reaction. The pressure has no effect on the equilibrium if the number of moles of gaseous reactants or products does not change. The change in pressure in both liquids and solids can be neglected in heterogeneous chemical equilibrium. According to Le-Chatelier's principle, because the volume of a solution is virtually independent of pressure. The third factor is temperature changes. In temperature changes, the effect of temperature on chemical equilibrium depends upon the signs of delta H of the reaction, and it also follows Le-Chatelier's principle. When the temperature increases, the equilibrium constant of an exothermic reaction decreases. In the case of an endothermic reaction, the equilibrium constant increases with an increase in temperature. Effect of a catalyst. The equilibrium is unaffected by the catalyst. This is due to the fact that the catalyst favors both forward and backward reactions equally. As a result, the forward to reverse rate ratio remains unchanged, and there is not net change in the relative number of reactants and products present at equilibrium. Thus, a catalyst has no effect on the equilibrium position. Effect of addition of an inert gas. When an inert gas like argon is added to a constant volume, it doesn't take part in the reaction, so the equilibrium remains in an undisturbed state. If the gas add is a reactant or product that is involved in the reaction, then the reaction quotient will change. And the third topic that we're gonna talk is example of chemical equilibrium. In chemical reaction, reactants are converted into projects by the forward reaction, and the projects may be converted into reactants by the backward reaction. The two states, reactants and projects, are different in composition after some time of the start of the reaction. The rate of the forward and the backward reaction may become equal. After this, the number of reactants converted will be formed again by the reverse reaction, such that the concentration of reactants and projects do not change anymore. Hence, the reactants and projects are in chemical equilibrium. And the last topic that we're going to talk is importance of chemical equilibrium. Chemical equilibrium is useful in many industrial processes, like the preparation of ammonia with the help of Haber's process. Here, nitrogen gas combines by hydrogen gas to form ammonia. The yield of ammonia happens more at low temperature, high pressure, and in the presence of iron as a catalyst. And chemical equilibrium can use in the preparation of sulfuric acid by contact process. In this process, the fundamental reaction is the oxidation of sulfur dioxide into sulfur trioxide. This involves chemical equilibrium.